Okay, so we are finally getting to the part of the lessons about matrices and what they are. So, for every item listed, in this lesson, we'll explore techniques for solving systems of linear equations by using matrices. You might recall that a matrix is a rectangular array of real numbers. So a matrix looks something like this. Each item is called an element. So each one of these 6 lowercase a's, these are all different elements inside the matrix, and they're identified by their position in the matrix. So for example, A21 means it's the entry that's in the second row, first column. So this A21 shows that it's in the second row of the matrix, but the first column. A matrix has m rows by n columns. So it's said to be an order of m by n. And each subscript ij identifies the location of that element within the matrix. So one of the first things we're going to be doing is just talking about what's the order of each matrix. And it really is as easy of a question as you think it is. This question's asking for letter A, determine the order of the matrix. Here we have a matrix that is 2 rows. See, we have 1 row here, and we have another row here by 2 columns. So our answer is that it is a 2 by 2. And that's it. Done. We're done with the problem. The next one, the order of this matrix. This matrix is 2 rows by 3 columns. So this would be a 2 by 3. This would be 2 by 3. We have 2 rows by 3 columns. Be very careful. It does always have to go in the order of rows first and then columns. So if we look at this next one here, this is what this is: 1, 2, 3 rows. 3 rows by 1, 2 columns. So be very careful. Notice how this here was a 2 by 3 and this is a 3 by 2. The order matters a lot with this. The order matters a lot. But that's how we determine the order of a matrix. All we do is say it's m rows by n columns. Something else we can do with matrices is we can actually use them to represent a systems of equations. So if we think back to our old equations that we had in systems of equation, can we see that from here to here, from the system of equation to an augmented matrix, all I did was I put, for example, 1x plus 1y plus 1z equals 3. 1, 1, 1, 3. 1x minus 2y plus 1z equals 12. 1, negative 2, 1, 12. Negative 1x plus 1y minus 3z equals negative 17. Negative 1, 1, negative 3, negative 17. I literally just took the coefficients from here, put them all here, and I put the numbers on the last column. Something worth noting, in our augmented matrix, the order does matter. This is x, this is y, and this is z. Well, from this augmented matrix, I actually could just get rid of the whole solutions column. I could just turn this into a coefficient matrix, where it's just a matrix of the coefficients on the systems of equations. The other thing that can be done is I can give you a system of equations and ask you to write a matrix that represents it. So I could give you a matrix, a system, x plus y plus 3z equals negative 1, y minus 2z equals 0, and x plus 3z equals 1. And don't worry, I'm not asking you to solve this yet. All I'm asking us to do is rewrite it as an augmented matrix. So for my matrix, I'm going to write it where here's my matrix. My first row is going to be 1x plus 1y plus 3z equals negative 1. So it's going to be, whoops, didn't mean to write there. Our first row is going to be 1x. So I have 1x, 1y, 3z, and negative 1. Our next one is going to be, there's no x here. So that means the coefficient in front of x is a 0. I have 0x, 1y, negative 2z, and it's equal to 0. Last but not least, I have 1x, I have 0y, I have 3z, and I have 1. So it's going to be 1x. Oops, don't need to write z there. I'm just writing the numbers. I'm not writing the variables in. The reason for that is it's implied that x is here, y is here, and z is here. So that's why I'm not writing in the variables with the coefficients. I'm going to close my matrix. And to show that it's an augmented matrix, we typically put like 3 dots right in here. Some people also do it with a vertical line. But either way would be fine in my class. You could do it with the dots, or you could do it with a, you could put a line here if you prefer that. Basically what that means is this represents the equal sign. So this here represents the equal bars, saying that this is equal to this is equal to this, and these are equal to this. That's what that vertical line represents. So you have to wonder, what could we do with this? It was easy to write it as a matrix. What could we do with it? And so we're going to be doing what's known as elementary row operations. So in the last lesson, we were talking about getting stuff into row echelon form. Here's the reason we did it. We're going to be doing something called elementary row operations. We are only allowed to do these 3 things. We can change the position of 2 equations. We can multiply one equation by a non-zero constant. And we can add a multiple of one equation to another equation. So I'm going to have my matrices 1, 1, 3, negative 1, 0, 1, negative 2, 0, 1, 0, 3, 1. This should look familiar. This is the matrix that we just made right here. And I want to show you what we can do. So I'm giving you the steps for this one. You will learn how to make these steps on your own. But for now, I'm going to show you these steps. And I'm going to do them very, very carefully. So letter A, I'm going to make a new row 1 by doing row 1 minus row 2. So here's what I mean by this, okay? Since I'm telling you I'm making a new row 1, I'm going to copy my matrix over. I'm going to leave row 1 blank for the moment, and I am just going to write everything else. So I have 0, 1, negative 2, 0. Here I have 1, 0, 3, 1. The reason I did this is because the only thing I'm making new is a new row 1. My new row 1 is going to be created by doing row 1 minus row 2. And we're going to do this here. I'm going to do row 1 minus row 2. I'm going from here to here. I'm going to do row 1 minus row 2. So when I do this, 1 minus 0 is 0. 3 minus negative 2 is positive 5. Negative 1 minus 0 is negative 1. So what we did was we copied rows 2 and 3 over. We did not mess with them. And all we did was we replaced row 1 with row 1 minus row 2. That's all we did. We're now going to go from here to here. We're now going to create a new row 3 by doing row 1 minus row 3. And it's okay if you don't understand why we're doing these things yet. That is totally fine. But what is super important is that I need to leave my row 1 and row 2 the exact same as before. So it's going to be 1, 0, 5, negative 1. This is going to become 0, 1, negative 2, 0. This one here, and my row 3, I'm going to leave blank for a moment. The reason these two copied over from letter A is because the only new row I'm making is row 3. To get my new row 3, I'm doing row 1 minus row 3. So I'm doing the top row here minus the bottom row there. So for example, 1 minus 1 is 0. So this is going to be a 0 here. The next one, 0 minus 0, well that's 0. 5 minus 3 is 2. Negative 1 minus 1 is negative 2. So by doing row 1 minus row 3, we created the new row 3 of 0, 0, 2, negative 2. We're now going to go to letter C. Letter C says we're making a new row 3 by just doing 1/2 of row 3. So that means my row 1 and row 2, I'm going to leave alone in this step. I'm going to copy them down. So I have 1, 0, 5, negative 1, 0, 1, negative 2, 0. And the only thing that's happening to this is my row 3, I'm going to be multiplying by 1/2. So 0 times 1/2 is still 0. 0 times 1/2 is still 0. 2 times 1/2 is 1. And negative 2 times 1/2 is negative 1. That's all I did from step B to C. All I did was multiply my third row by 1/2. Let's go from C to D now. Here I'm telling you, Here I'm telling you that we're creating a new row 1. We're creating a new row 1 of row 1 minus 5 row 3. So what that means is I'm going to copy down my rows 2 and 3 because I am not changing them. My row 2 was 0, 1, negative 2, 0. My row 3 was 0, 0, 1, and negative 1. And the only thing I'm changing is I'm doing row 1 minus 5 row 3. And this one is a little tricky, so I'm going to write out row 1 and 5 row 3 so it can be a little easier to see. Row 1 was 1, 0, 5, negative 1. And then 5 row 3 is 0, 0, 5, negative 5. This is row 1, this is 5 row 3. I got them from letter C here. I now need to subtract these things. I need to do row 1 minus 5 times row 3. 1 minus 0 is 1. 0 minus 0 is 0. 5 minus 5 is 0. Negative 1 minus negative 5, watching for the double negative there, is positive 4. Watching out for that double negative there is positive 4. Almost done. Now to get to letter E, we're going to make a new row 2 by doing row 2 plus 2 row 3. It's alone, so that's 1, 0, 0, 4. I'm going to leave my row 3 alone because I'm only making a new row 2. So that's going to be 0, 0, 1, negative 1. And the one I'm going to be careful about is I'm doing row 2 plus 2 row 3. If it makes it easier for you, write it out. My row 2 was 0, 1, negative 2, 0. And I'm adding 2 times row 3 to it. So 2 times 0 is 0, 0. 2 times 1 is 2. 2 times negative 1 is negative 2. I'm doing row 2 plus 2 times row 3. 0 plus 0 is still 0. 1 plus 0 is 1. Negative 2 plus 2 is 0. And 0 plus negative 2 is negative 2. This matrix here is our final answer. This matrix down here is what is known as, is what is known as reduced row echelon form. See how we have ones along the diagonal here and zeros for every other coefficient? This is what is known as reduced row echelon form. That matrix that we just made, the matrix of 1, 0, 0, 4, 0, 1, 0, negative 2, and 0, 0, 1, negative 1. This matrix that we just made just represents x equals 4, y equals negative 2, and z equals negative 1. Because remember, this first column is the x's, this second one's the y, this third one is the z. This first equation says 1x plus 0y plus 0z equals 4. The second one says 0x plus 1y plus 0z equals negative 2. And the third column says 0x plus 0y plus 1z equals negative 1. So we found the solution to this of 4, negative 2, negative 1. And we found it with what's known as reduced row echelon form.